Right, hi, great stuff. Welcome back to this channel. Thank you very much for joining me today. If you're new to the channel, please ensure that you have subscribed and turn on that notification bell so that you can be notified every time when we upload a new session. It's quite an interesting question adapted from your May-June 2023 and it's on calculus optimization. Guys, do remember that we have a session on application of calculus optimization, right? Um, I'm just gonna post it also on the description of this video. You can click the link and go and watch it, right? Quite an interesting session to give you a background of this quite challenging section in your calculus. All right, so also you can check on your screen. I'm just gonna put it there and you can click it as well and go and watch that one first. Okay, it's optimization. It's the first session really in your calculus that we did. Okay, quite an interesting session. Today we're gonna look at this question. It was question 9, quite an interesting one, and it's on application of calculus. Without wasting any time, let's get straight to it. Okay, so we are given that a wire is 12 meters long, right? It is cut into two pieces. One part is bent to form an equilateral triangle and the other a square. A side of a triangle has the length of 2x meters. Write down the length of the side of the square in terms of x. Okay, that's the first question really. So we are told that there's a 12 meter long wire, right, which is then cut into two. So to show that we are dividing this into two, we are cutting it into two, so we have two pieces, right, that amounts to this 12 meter long, right? Then what is happening is that the other part, it has now created an equilateral triangle. Remember, an equilateral triangle or side are equal with a length of 2x. Okay, so obviously if we are to express all the perimeter of this equilateral triangle in terms of x, this is 2x as well, 2x as well, it will be 2 4 6, so this will be 6x. Okay, the other one is then forming a what, a square, in which we do not know these sides in terms of x. So that is what the question wants. Find the sides in terms of x. We know that a square has 4 equal what, equal sides. So I'm just gonna say 4s, and we're gonna solve for that s and express it in terms of what, in terms of x. Okay, so that's how we can actually do it. So now we have it like this, so we can go and solve for s. So in terms of x, so this will be 12, I transpose 6, it will be minus 6x is equals to 4s. Then to find s, the side, which is the side of the square in terms of x, I'm gonna divide by 4. Why am I dividing by this? So I'm gonna divide by 4 because I want to eliminate 4 there. So I have 12 minus 6x divided by 4. This will be the side of the square in terms of x, hence it's just 2 marks, right? You can choose to simplify it to say 12 divided by 4 minus 6 divided by 4x, right? Then it will give you 3 minus 3 over 2x, okay, as the side of the square in terms of x. All right, let's go to 9.2. Okay, so 9.2 is saying if this square is now used as the base of a rectangular prism, right, with a height of 4x meters, determine the maximum volume of the rectangular prism. Okay, so you can see that this is an optimization question, or rather application of calculus, And the keyword that allow us to decide is the term maximum, right? Maximum volume. Okay, do recall that if we are to maximize something, to minimize something, basically it comes from the notion that if we have a cubic function to get the maximum value of x in these turning points, what we do, we know that the first derivative is equals to 0 at that point. The gradient is 0. Then you can solve for x. Okay, when you solve for x, you'll get two answers where one x will be for the maximum and the other x will be for the what? For the minimum. Okay, so that's the idea here. So in this case, we need to get the maximum volume of the rectangular prism. And if you can refer to our first session of optimization, we did mention that if you are to maximize something, you must first get a mathematical equation or an expression for something you want to maximize or minimize. In this case, we do know that it's the volume of the rectangular prism, so we need to get a mathematical expression of that volume of the rectangular what? Prism. Okay, they told us some important information. They said the base of that rectangular prism is a square, right? It's a square. Okay, so obviously we have indicated that the side of this square is 3 minus 3 over 2x, right? Because all sides are equal in a square. So that's the expression of the side of a square. We do know that the height, right? Let's say this is the height. It is given as what? As 4x meters. Okay, so now let us now go and get first the expression of something that we want to maximize, that is the volume of this rectangular prism. Okay, so the volume, obviously guys, volume is the same as area of what? Area of base multiplied by perpendicular height, or the height. Okay, so in this case, volume V, area of base, our base is a square. And what is the area of a square? It is side squared. Okay, times what? It will be times height. Okay, because any volume of any shape, you just say area of base times perpendicular height. So in this case, we are told the base is a square, and we know the squared area is side squared. Okay, our side in terms of x, it is 3 minus 3 over 2x squared times, what is your height? We are given in the information that our height here, it is what? 4x meters. So your height is 4x. Okay, now we can go and get that expression of volume in terms of x. Okay, so we can simplify this, we can expand this. So when you expand, it's gonna be 3 times 3. You know, when you expand 3, you open two brackets like this, 3 minus 3 over 2x, like that. Then that times that, 3 times 3 will be 9. Okay, so 3 times minus 3 over 2, it will be minus 9 over 2x, then minus 9 over 2x, then plus 9 over 4x squared, and this is multiplied by what? By 4x. Okay, so let me just write this side. So as you are simplifying that volume in terms of x, you can add the like terms. You know, you have minus 9 over 2 and minus 9 over 2. Okay, that will give us minus 18 over 2, which is just minus 9. Okay, so we now have 9 minus 9x plus 9 over 4x squared. This is multiplied by what? By 4x. Okay, now we can remove with this 4x, multiply every term by 4x. So 9 times 4, it's gonna give us 36. So we have like 36x. then minus 36 x squared. Then we have 9 over 4, which is multiplying 4. 4 and 4 will cancel. Then you'll be left with 9 x squared times x cubed. So that is your expression now of the volume in terms of x. After getting the expression of something that you have to maximize, that is in this case where we want to maximize the volume, we now have the expression in terms of a single variable, which is x. Then we can now go and get the derivative. Why are we derivating? We do know at the turning point, in order to maximize something, right? At the turning point of the cubic function, we say first derivative equals to 0, and that enables us to get those x values that will either maximize, another one will minimize. Okay, similar notion in this case, we have to derivate this volume. Then it will be 36 minus 36 times 2, it will be 72. Then x2 minus 1, x exponent 1. Then we have plus 9 times 3, which will give us 27. Then we say x exponent 3 minus 1, it will be x exponent 2. Then what do we do next? We let our first derivative to be equals to 0, just like you do if you have your cubic function at the turning point there. You let your first derivative to be 0. The first derivative is 0. Then you can go and solve for x, which will either maximize or minimize. Okay, I'm just gonna delete this, guys, because of space, and let's see how it goes. So it's going to be 0 is equals to 36 minus 72x plus 27 x squared. We can just write it properly. 27x squared minus 72x plus 36 is equals to 0. Then we can take perhaps a common factor here. Okay, so if we are to check, if we divide, we can divide every side by 9, right? So if I remove 9, I'll be left with 3x squared. Then 72 divided by 9, it will be minus 8x plus 36 divided by 9, it will be 4 is equals to 0. Okay, so if you divide both sides by 9, you'll be left with 3x squared minus 8x plus 4 is equals to 0. You can open two brackets, or if you don't want to do this, you can use your quadratic formula, and you could use it at this step, right, and get your x values. Okay, so in this case I can choose to just factorize 3x and x. Then 3 times 2, 6, then minus 2, it will be 8. So it's 2 and 2, minus and minus. So you have 3x minus 2 equals to 0, or x minus 2 is equals to 0. Okay, then you have x will be equals to 2 over 3, or x is equals to 2. Now you have two values of x, right? But remember, one of these value will give you the maximum volume, one of them will give you the what? The minimum volume. Okay, we have to decide which of the two x values will actually give us the maximum volume. How do I decide? Okay, so obviously to decide, what you can do is you use the second derivative. Okay, so this idea that if the second derivative is greater than 0, then that x value will actually minimize, will give you the minimum. But if your second derivative is less than 0, that x value will what? Will maximize. Okay, so that's the notion there. So what we can do to test which of the x value will give us the maximum, we can go and find the second derivative. Or if you don't want, because the question here is saying determine the maximum volume. We can just test and come and substitute this x equals to 2/3 on your expression of volume, and you'll substitute x equals to 2, and you'll choose the one that gives you the biggest volume. Okay, that will be the one that will maximize. But we can still, test which of them will actually maximize and minimize. So I'm gonna get the second derivative. From here, 36 will be 0. This will be minus 72 plus 54x. Okay, that's the second derivative. So if I now substitute, if I come and substitute this, what there is x, right? X equals to 2/3, right? It will be 72. I'm just doing it on my calculator. 72 plus 54 into 2/3. The second derivative becomes negative, right? It becomes here. When I substitute this one, 2/3, I'm getting of 2/3, second derivative of 2/3 is negative 36, right? Remember, we are just doing this to decide which one will maximize, which one will minimize. Okay, now if I substitute these two now, where there is x on your second derivative, so I'm saying minus 72 plus 54 into 2, it's gonna give me positive 36. So this 2 is giving us what? Positive 36. Okay, I think I'll just have to erase some things here for the sake of space. So this one, when x equals to 2, the second derivative when x is 2 is giving me 36. You can see for x equals to 2, second derivative, it's actually what? Greater than 0. This one will give us the what? The minima. When x equals to 2/3, second derivative, it's less than 0. It's negative. It's negative 36. It's less than 0. This one will be the one that will what? That will maximize. Okay, so we can now go and finally get the answer and answer the question, right? This forms part of your answers you're answering. So when x equals to 2/3, this is the x that would actually maximize. Okay, because we saw the second derivative was actually less than 0. Okay, this one will maximize. So obviously, to get the maximum volume where there is x, I'm going to substitute 2/3, because this is the x that maximizes. 2/3 minus 36, 2/3 squared, plus 9 into 2/3 cubed, because the question wants us to get what? Determine the maximum volume. Okay, so we're gonna say 36 into 2/3 minus 36 into 2/3, right, squared, plus 9 into 2/3 exponent 3. Okay, so the maximum volume will be 10.67. This is in meters cubic, what? Cubic meters. Okay, you can even prove with 2. When you substitute 2 here, you'll actually get a very low volume. You won't get the one that will be greater than 10.67. Okay, so that is our answer. What is the maximum volume? 10.67 cubic what? Cubic meters. Okay, I hope you find this helpful. Please ensure that you have subscribed, turn on that notification, like and share and comment, and let's see you soon. Bye.